Let's talk about such a strange thing as process mining and its application to suggest the analysis of software systems. And okay, so let's so my suggestion would be, guys, so just let us agree right away that so if you want to ask me something, so just if something is not clear, or maybe so you would like just me to explain something again, or maybe to get back to some slides, so please feel free to ask by voice or using the Zoom chat. So I love questions, actually. See, we have more or less enough time, so I think we'll have time to discuss everything, so do not hesitate to do that. So probably you may have already seen me, so I introduced myself the opening of the school, as I helped a little. I helped a little Sergey Shershakov with the organization of the school. And so actually the subject area of this school coincides with what I do at the Harvard School of Economics. And you see that in particular, I supervise the master's program, which is called System and Software Engineering. And so let me take, please, this opportunity to tell you a few words about this program. Well, firstly, this is an English language program, so all classes are conducted in English. So we suggest recruit foreign applicants for this master program. Moreover, through a separate competition. So we have a competition for Russian applicants and suggest another competition, another path for suggest foreign applicants. And we actually have, I guess it's 5 places that are covered by the state scholarships. So this is just a good opportunity, good chance to apply for admission. And by the way, so it's just a portfolio, so you only need just to show us your skills and so your achieves and something like this one. And so here we can see those who grow out of our students. These are team leaders, software architects, software project managers, and so on. And usually guys who already know how to develop software come to us, and they want to learn how to do it on an industrial scale. So let me say that. And of course, with the industrial quality, which is quite important here. So all the courses are interesting. Most of them are unique. And what is interesting is that many of these courses are related to what you have heard or will hear at the school. And we also have a double degree program with the University of La Peruanta. So generally, I'm waiting for all of you guys, of course, Russian applicants too. So all the details you can find on our website. So, or you can contact me and so just ask all your questions about this program. So just welcome. And now, so let us discuss what I'm going to consider during this talk. So I would like to reflect the following points. Since process mining is a relatively new scientific direction, so I'll start with its main tasks and current problems. So I'm going to show you some examples, a couple of models and event logs. Then in the second part of our class, so at the second and the next class, we'll go a little deeper into some aspects of representing event logs using a database, and so just consider how to just apply the practices and the techniques of process mining for solving quite practical task. So this task, this real task went from the industry, and so the task is related to finding anti-patterns in the event log of a large and complex IT system. Okay, so let's move on. Let's move on now and discuss what process mining is. And so I presume it's just something new for you guys. So I'm going to talk a very few words about importance of processes, and so that the processes around us actually they are. So may I ask you just to press a plus in our Zoom chat if you have heard about process mining before. So just before this event, minus if it's something more or less new for you, so just some fresh words, fresh title, in some sense, you see. And yes, again, so we're talking about processes, and you know that some modern processes are becoming more complex and faster. And actually, now the implementation of any complex processes is unthinkable, I guess, without the support of information systems, which gave rise to a special class of so-called process-oriented information systems, or sometimes they are called process-aware information systems. So these systems are working, and so the point is that so they generate a large amount of data containing about their work, the work of this process. This data is normally called digital traces, you see, and the point is, so the interesting point is that such digital traces are a quite valuable, rather valuable source of information about the actual behavior of this processes. These information systems are working for, and so just implemented these processes, you see. And the point is that so you can use this data, you can use this information in order to find what's going on, in fact, in your system, what's going on with your business. So you can use it to control also just your processes, your business, to understand it, and so just to improve it when so just if it's needed for some reasons, you see. And again, the point is that so if you look around us, so you can see the process just everywhere, and they are complex enough, so just to they're tricky enough to so just to make dealing with them quite so just complex procedure. And sometimes the processes become so complex that it becomes difficult not only to manage them, but even just to understand them. So, for example, like this, you see, however, so this is just at least a structured process. So you can see here another approach, so just illustrating what's going on in some team or something like that one. Gosh forbid, like this, you see. So such kind of models are normally called spaghetti models. So just because you see, so these relations between individual tasks, individual actions, individual agents involved in this process are quite complicated. So it looks like spaghetti, so just macaroni, and so of course it's quite complicated to understand, even to understand such a model. And so just what should we do? This is just a question, and actually, in order to get an idea of what is happening with such processes, it's better just to have some sort of graphical model, you see. And so, for instance, it can be some graph-based model, just simply a graph, you see. This specific example simply shows a graph that displays the relationship between individual actions involved within a certain process. And it's quite, quite easy to understand what this model depicts. So this is just example of another kind of another sort of model. So it's known as a transition system, or maybe it's more understandable or more familiar. You are more familiar with these models named as finite state machines or finite state automatas. So again, I like a kind of interactive. So just may I ask you again, guys, to press plus in our chat if you know what finite state machines are, and so what are they used for, okay? So just in order to get some statistics for that. So for example, am I correct that it was yesterday or maybe just on Monday we were discussing just coffee machines, and yeah, it was yesterday, so it was the very beginning of the Kotlin day, and so we were discussing our habits of drinking teas or coffees, and so I mentioned that I have one. And exactly this is just my preferable coffee machine. It's called Ranchillo Miss Silva. And strictly speaking, it's just a boiler, you see, which boils water properly. Because it must be stabilized in terms of its temperature, in terms of, the pressure of the water, something like this one. And so actually there is some specific mechanism, some specific scheme inside of this machine that also can be represented unit such kind of model. Which is known as to be finite state machine, because it's very descriptive and so just very understandable, and it's also quite expressive. And it turned out, guys, that not only just the the coffee machines can be explained using such kind of by using such kind of models, but also you may use finite state machines, finite state automatas to illustrate what's going on with your processes, with your business processes. See. And there is just so-called Petri nets. They are quite important in the domain of process modeling, because they can be used perfectly to depict the processes, a process containing what is called concurrency, or even true parallelism. You see, so if you have some just independent ways on some specific part of processes that can be executed independently. So such kind of models can depict such behavior more compact, and they also quite good for checking very important properties that are called safety properties. So we're going to just mention them very little a bit later. So, but the initial idea, what is interesting with Petri nets, and this is why I'm going to spend some time discussing them, because they they play an important role again in the process modeling domain, and so they are working at the backstage of suggest more some other types of models that could be more suggest known for you, such as BPMN, or say some UML diagrams, UML models. But the interesting point regarding Petri nets is that so initially they were such kind of model, such kind of formalism. So it's a formalism which describes what is called dynamic discrete system. So the system with states that can be changed, states mean can be changed, so just under some external, also just external events, And again, interesting point is that so initially Carl Adam Petri, the inventor of this model, was using them to model chemical, chemical processes. There were several particles here, so we get one from here, get one from here, then there is a reaction, there is some transformation of these elements, and then you have another element here, say just I don't know how to call them, one molecule of water or something like this one. Then these models were adapted for representing processes. And here you can see that there is almost the same as it was represented previously. Here we have, actually it's a graph, nothing else as graph, and it's called bipartite graph. So you can see that some components of this graph are represented using circles. You see these circles C1, C2, C3, C4, and another represented using these rectangles. And these rectangles correspond to these black just bars. So this is just a bit different notation for exactly the same idea. So the point is that these just circles are called places, and so these rectangles are called transitions. Places, according to their names, they are something to store what is called resources, you see. And again, as in the case with chemical reactions, so resources here are represented using these black, these black dots, which are called normally tokens. So tokens, as you know, in any there's game, something like this one, you see. So they are moving. Tokens are moving through this model. They can be placed only in place components. And transitions are something that reflect executing of another stage of a process. Say, you can see that some edges here, some arrows here goes inside transitions, and another also go outside transitions. And so when a transition is being executed, so we call it that transition is fired. So it consumes a resource from any input places. So for example, here start is an input place for such a transition and produces new resources to any of the output places. So, and here tokens represent the current state. And so in order for a transition to be executed, so there must be just a condition held here that so in all input places there is a resource, and so try to reflect it to the real business situation. So in order, say, to check some ticket, you we need to so this is just a scheme again, guys. So just an example. So this is just a scheme, a model representing dealing with some compensation handling or something like this one, you see. And so before you start checking ticket, you have to register a request for this compensation. And so it is being shown by this model that so before checking such a request, we simply can't go further. Can't go further. So these models are more or less low level. However, So just in industry, so just related to business process management and so just process and analysis. So there are some other models based on Petrynets, say BPMN. So again, guys, let me just disturb you and ask you, so whether any of you heard something about BPMN notation, maybe at some courses or maybe during your work activities. I see pluses here in the chat. Great. So well, okay, according to the name of this notation, so it's business process model notation. So it looks like the Petrinet so just discussed previously. However, so there is some special graphical components depicting what is called so just joint components, joint and forks components, you see. So these components, these elements show how the process could be so just parallelized, or then so after each independent part of this process so just finished properly. So this process again is so just join to the single point, and then so just continue traveling through this model, you see. And so it's quite popular in real applications because it's quite descriptive. Again, it's expressive, and it also can be quite precise, quite accurate, which is important for modeling, because so we may consider, and so it's quite easy to show that sometimes a process can face some unnecessary so just cases called live logs, deadlocks. So such cases when a process can simply move on because of some requirements for another stage of the process are not satisfied, you see. So these models can be used to show whether your processes are configured properly or not, for example. So then, okay, so these models, so this one low-level model, so this one is used for process analysts, by process analysts, and so there are UML, so just family of models. So UML stands for Unified Markup Language, and so here, so we approaching what is more important for software guys like me and you. And again, so I'd like to ask you guys to press plus in our chat if you know anything about your UML standards. Oh, so now we have a lot of pluses, okay, so just it's clear that so it's important for you guys. And you know, yeah, guys, that's UML, it's just a family of different models, of different approaches how to describe so a configuration of a complex system, or so just it's a family of a group of so-called structure diagrams, or alternatively you may depict behavior of a system. So again, it could be complex or maybe less complex system. So just sometimes you need to depict how it behaves, you see. And so we start with activity diagram. So we would like to simply touch on which sort of models we have. And we start with activity diagram, UML activity diagram, because of, you know, this is nothing else as almost nothing else what we have seen previously, this one or that one. So this is just so we may think of UML activity diagram as just a bit different graphic notation for the same Petrinet models. And those of you guys who used to deal with these models, actually dealt with Petrinet models, but expressed using a bit different graphical notation. You see, so again here you have some start positions, and you have forks and joint elements. So you have some parallel constructions, and here the most important part is just some actions so that are executed during another, so just run of this process. And so now I used run of a process term, and so again, so just the topic of our of our class is system runs analysis. So it leads us that so we have some runs so just describing the execution of a process for a system. So, and actually this is what we're gonna to analyze using the approaches I'm going to face. I'm going to reach soon. And Uml state machine diagram again. So even so just if you didn't consider them, these diagrams, these sort of models in your practice, so you can easily understand it, because it's nothing else, again, nothing else as another representation of well-known finite state machines. Yeah, finite state machines are quite powerful and important approach to modeling such as behavior of a system. So there was a special model type, so just standardized, so just involved in the UML standard. You see, so it also uses special graphical notation, which makes it looking similar to, you see, to some other models from the UML. So just family of models. However, it's almost nothing else as just another approach to depict a finite state machine. Finite state machine. And another type of diagram, use case diagram. I guess you also may so just look them previously. So it shows how so just the system. So depicted here, you see the important part of the system. So it's boundary. So just some part the system can't so just break through. You see, and you see some external environment of the system, so expressed in terms of agents or users, or possibly another, so just another systems interacting with the systems depicting in this model, you see. And so we have UML use case diagram for modeling them. So frankly speaking, most of these models can be observed during the courses called system design, or so just enterprise system design, maybe advanced system design. We have such a course actually at our master program. And this is just important for those of you who want to suggest acquire skills higher than just to be a very good programmer. So it's very important to you guys to understand how to suggest to model a software system. You see, and so this is just a kind of standard, sort of standard that just must be known for you in order to be able to understand what other guys have done while designing so this or that system. This one was a kind of interaction diagram, and there is another another sort of interaction diagram. It's called Uml Sequence Diagram. So it's very useful actually, even if you teaching programming at the say so just first year students, freshmen, sophomores. because it's very useful and it's very convenient to depict interaction, even a very simple execution agents such as procedures or functions or routines. And so this diagram shows that you have objects that are interact with each other. It could be an object expressed in terms of classes, or it can be simply a function or procedure, you see. And then we have a set of messages being sent by this function, by this object, you see, to another. So just to another object. And then we have responses here. So by using solid lines, we show requests, and using dash lines, we show responses. So this diagram in particular will be helpful for us to discuss the second part of our today's event, related to so just analyzing a real system, because so we'd like to wishing to depict interaction, possibly suggest interaction violating some rules or some suggest principles, architectural principles, using exactly this diagram. So this one, so just please get a tick in your mind. So this diagram will be helpful for us. And okay, so there is one more. It's called BPEL. Standing for Business Process Execution Language. So this one is used mostly when you deal with what is called service-oriented architectures. And again, this is what we are going to look at the second part of our class, because we're gonna analyze event logs of a system made of these very principles of system-oriented architecture. And so BPL is a special language. So it was designed specially for describing interaction of services between each other. So it's quite formal, and it's still being used quite intensively. It's worth knowing that so together with BPEL, BPMN mentioned by us previously is so just also quite intensively used for describing a behavior of a model, or even just prescribing how these services must interact with each other. So let us simply consider that there is such a model, and what we have to suggest discuss now is that so all this stuff, guys, I've mentioned, so this wasn't actually something new in terms of, you know, the teaser that was given for you. That so there will be a bit new, discipline, a bit new approach, a bit new scientific direction called process mining. You see, so all that stuff was known, have been known for years. And so it was used, have been used for years for modeling, for describing systems. And you see, there is just a lot of areas involving of what we call process-aware information systems. But the point and the question is where in this very system of so just different domains, so just intersecting with each other. So where there is so just a room for process mining and what it is about. Say when we discuss business process management, so there is quite major, technique, quite major discipline, and has been known for a long time. Actually, this is quite applied discipline, which is already quite mature, and within which the best practices have been developed and fixed. And by the way, actually, so I wanted to note that when it comes to business processes, we're not limited only conditionally to sales or purchases. You see, so just even a formalized, any formalized workflow can be called a business process. So even you have a technical process, say, so just a process describing behavior of some electronic system, say, you see, it also can be formalized and expressed in terms of business process. So this is especially important for those of you guys who are Russian speaking natives, because so just there are what is called some subtle details of translation, you see. So for Russian persons, so when we are talking about business processes, it's look like so it's something related to, you know, again, to sales. It's not, it's just details, you see. It's only one particular way to apply, so just what is generally called business process. And getting back to process mining, what is it for and what makes it different from all that stuff I mentioned previously? And again, why we call it a young discipline. And well, so the main goals, so just strictly speaking, the main goals and objectives of process mining were formulated already. So just there is a kind of policy document, or how to call them, which is called the Process Mining Manifesto. So this is just a quite complex document with a huge number of authors. So just associated with this document, maybe so just several dozens of authors. So there, so just all the guys involved in so just in the writing of this discipline by the moment when this manifesto was created. So just they are mentioned as so just its authors, you see. And so again, so we were talking about goals and the objectives, and the most important of them, so just can be commented on by the following picture. So the point is that, so okay, we have process-aware information systems. They're working and producing a lot of so just digital traces, those digital traces we mentioned, you see. And so these digital traces are accumulated, so they are stored in some storages. And so initially, actually, so the format of this data was not specified somehow to the case when someone is going to use them for analyzing so just business processes or simply processes. So it was simply, and is still being simply technical logs, what is called technical logs. You know, guys, when you write, when you code an application, some piece of software, so in order to be able just to get a feedback from the user of the software, so you're better just to add to inject such a sort of logging system inside your software, because so just when you have a lot of users for this system, which are distributed possibly all over the world, we consider so just more or less huge system or more or less popular systems, of course, yeah. And so so it's quite clear that so it's not possible simply to interact with each such a person directly in order to get what went wrong with a very specific in the very specific case regarding to the invocation to the using of this software by that user, you see. And so it's better simply just to make an ability for such software to make technical logs that can be further analyzed by so just special analysts, so on, and using these logs, so you may simply get all necessary technical information about what went wrong with your system, you see. And actually, process design and modeling are carried out, so just carried out by normally by process analysts as well. So they are dealing with processes, not with raw logs, technical logs. And so they use different, so just different models for that, you see. So we mentioned, so just different sort of models. And let's, for example, some process model is developed by an, so just analyst. So here we have analyst, here we have a process model, and so just say we have an information system, some process-aware information system, which is configured in accordance with this module. And in the course of its work, of the work of this model, there could be, so just there is a room for some deviations from the initial model. So such deviation may appear. You see, so they can relate to, say, human factor, you see. And well, so now such deviations will be recorded in the event logs. And what we can do here, so we can compare the original model, which is called prescriptive model, with so just actual execution, so just recorded in the event log. So we have a set of runs, so they are recorded. We may simply found such inconsistencies, you see. And so this is what is called conformance checking. So this is just the first task of process mining. So we have three major tasks, three main tasks we're going to discuss here. So first one is conformance checking. So then we have we have a second task. So we have what is called a synthesis task. Actually, frankly speaking, so just synthesis of models, so just as an idea, so just when you have some algorithm and you have some input data, so the idea of automatic synthesis of a model on the basis of this data is not new at all. It was again, it was known for years. And so here we simply want to reuse the idea of the synthesis problem, but so this time we are passing event logs, so just as the input data here, and the output of such, you see, such a, how to call them? Such a procedure, such as an analyzing procedure, would be a model, see? And you may use this model. So now we have a log, we have an automatically inferred or constructed model, and sometimes it's called discovering a model. Yeah? We have digital traces, we have an algorithm, and we discover a model. So this is the second task, this is discovery model task. And finally, having some model, and so just recording of the actual behavior of the process. We have something what should be done and something that has been done, in fact, in reality. So we can correct this process, so we can improve it. So, and this is the third one, this is enhancement problem. So these are three problems that the process mining so just deals with. And frankly speaking, the research this research discipline, process mining, sometimes it's called process extraction and analysis. It relates to, data mining. So I guess so you could be much more familiar with data mining. And so the quite natural question arises whether process mining relates to data mining. Of course it does, because it's just some variant of data mining aiming to processes. You see, so we have the same, again, a lot of data, and we'd like to extract some valuable, so just knowledge from it. So we would like to convert this data to money, actually, you see. And so these techniques allow us just to do that. So this is why we call it process mining, similarly to data mining here. And by analogy with data mining, the important task of which is to extract some valuable knowledge from the accumulated data, process mining solves the same problem in a bit narrowed context in relation to process data. Actually, it's actually quite relative discipline. So maybe it's 10 to 15 years, as suggest researchers have been spending their time and their power to liberate this discipline. You see, however, we just have a quite large international community so far. You can see here just most suggest huge centers, research centers related to process mining, so which are dealing with process mining when there is a suggest research team. And one of such a center is in the Higher School of Economics here in Russia. We have a laboratory which is called, at the Faculty of Computer Science, which is called Process Aware Information System Laboratory, and I'm just one of the research fellows at this laboratory. I can guarantee that, guys, that we were the first guys in Russia who started dealing with process mining. So the godfather of process mining, well-known Professor Will van der Walst, was our scientific advisor several years ago, and now he is honorable supervisor, just of our laboratory. And now process mining is being spread across the world, actually, because big business just was able to see that it can give quite benefits to implement process mining techniques to improve processes, and just to find bottlenecks, to find what's wrong with a very specific process, which leads actually to wasting money, you see. And several years ago, there were a lot of, how to call them, contacts from different banks, just insurance companies, who came to us just to discuss how can we do business together, just how can we implement process mining for their businesses. So each, more or less, big bank now is using process mining for their internal processes. So let's get deeper, just a lot in the topic related to process mining, and let's look what makes process mining, you see. So again, there were enough techniques the process mining adopted to to use together with, you see, some new approaches. However, there is very very important point which makes it distinctive from some other data mining related techniques. or even suggest process analyzing related techniques, or business process management, even business process management. There is an entry point. So here we have so-called suggest a mandatory component that must be involved in any suggest in any you see analysis suggest which could be called process mining. So, and this is just event log. So now we're gonna look at what event logs are, and so what are the important components? So what are the components event log consists of? So first of all, it's an event. So now, we are moving to the more technical part and more formal part. So maybe before doing that, so I have to ask you guys whether you have some questions or maybe some suggestions, some notes regarding what I was talking about. Really? Okay. So let's just move on. Is code mining also a thing? Possibly not. So just it depends on what you suggest, what someone suggest called to code mining. You see, actually, what we are going to look at is how one can reproduce the way the components of information system are interacts with each other. So of course, such kind of interaction can be coded. And we may even just to make what is called reverse engineering. But so it's not directly what could be called code mining. So, okay, so let's move on. So event. So this is just an atomic component of event log, and it consists, so just an event contains information about suggest a single action. So this action is suggest was executed in the suggest in the scope of some process instance, what is called process instance. What does it mean, process instance? Say you have suggest a process of buying something. So you have to suggest withdraw money, you have to make an order, you have to suggest pay money, and then you have to get suggest what you have ordered, you see. So this is just a general process, and when individual clients, suggest people do exactly this procedure for buying something needed for them, so they produce actually just instances of a process, you see. And now I mentioned an instance involving 4 events, you see. So just withdrawing, making an order, what else? So just paying money and getting the goods. And so I mentioned 4 events, and they are connected to each other in terms of, so they are united by a single, just a single process instance. And in terms of log, you may see such sequence of events united by a single process instance, suggest technically it's represented by a trace, you see. And finally, an event log is a multi-set of traces, of different traces. So here you can see an example of what an event log can look like, you see. So there is a table, 2-dimensional table, yeah. So, and you can see, so this table consists of attributes, some columns attributed by some, by some name, data type possibly. So you may associate a data type for such a column. And then you have rows, and each specific row represents a single event, you see. And so this is actually quite similar to what you can see in your spreadsheet application, in Excel, say, or Google tables, you see, or Google Sheets, or whatever it's called, you see. This is what you can see, a CSV file you using to just to perform some analysis using Python analyzing packages. You see, you can see that using a database manager, so which can show you what is called a relation, you see, in terms of relational algebra or relational suggest calculus, you may suggest also represented as a two-dimensional table. So here an event log is just a table with suggest some attributes, and what you have to do is just to map these attributes to three important components. We're going to discuss them in detail a bit later. So they are first important one is the case ID. So it determines a single process instance. So then we have activities. Activities, this is actions that are being done during a process execution. And so we need a key to order them properly for make proper ordering. So most common an attribute associated with a timestamp is used for that. And so if you have such a mapping, we may simply remaster this log, or we may simply think of this log as it would be a simply suggest a set of traces. So one trace, second trace, third trace, like a string a text file here. And each letter here, a single character, represents a single action from the initial table, you see? And so say we have some duplicates. When we have duplicates, then we have what is called cardinality, and this is why we consider a log not simply a set of traces, but a multi-set of traces, which means that some specific trace may appear twice or so just more times, you see. So now we have a set of activities involved in this process. So they enter invoice, you see receipt, receipt receive. So what we have purchase order approve and so on. So if you simply consider the set of all unique activities, then we may deal with it when we do some process mining algorithm. And the size of log, generally the size of log is suggest a number of traces included in this log. You see, so this is just a bit of more or less formal definition on what we have when we're discussing an event log. Again, an event log is a crucial point here. So it involves involves process mining in our suggest analysis procedure. So let me show you another example again. So here we have an event log. So it almost the same table. So it just its representation looks a bit differently. You see, so. And we grouped all the rows from this table using case ID attributes. So we simply consider individually a group of events where having suggest case ID attribute equal to 1. So another group for 2, another group for say 10 or 42. You see, 42. So we simply group them, and then inside each of such a group, we order the events suggest according their timestamps. So what we have now, the first group. So it just the first group, the first case, the first trace. We also can call it a trace because it consists of 5 actions, 5 events. So it's just a case consisting of 5 events here, and they register request, we examine thoroughly, check ticket, decide on the check request, for instance. So for that client, okay, so unfortunately for him or for her, so his or her request was rejected according to some ideas, you see. So again, grouping information, ordering information, and actions, letters of that alphabet of actions, you see. And well, okay, so there could be some resources involved in the process. if you need that. So if you use an algorithm which can take into account resources, so then we have another columns or another attributes in your entity representing resources. Here we have so just Pete. So looks a bit impolite if we consider real people as to be what is called HR, human resources. However, so okay, so they are from technical point of view, they are resources, or say some cost associated with an event. Possibly, so how so just expensive it for a client or for a company just to make such an action, you see. So if you need to perform, say, some performance analysis or just to calculate what is the bottleneck in terms of money or in terms of cost, how so just expensive is it, you may use this resource to make such an analysis. Well, okay, then we suggest this case study, this activity timestamp, yeah? And so then we apply a process mining algorithm. Which one and how this algorithm work, it's a very big separate topic. So we're not going deeper inside to any of this algorithm because so we may simply consider an individual talk to discussing different algorithms. However, so if you're interested in that, so the cost mentioned in the cost of carrying out an activity. So I have a question in the chat. Yeah, and carrying out an activity. So for instance, you may simply associate some, you see some resource with an individual activity. So possibly only very specific individual activities will be so just associated with the cost, and others simply will be associated with some zero value, you see. Yeah, so this cost is so just these costs are associated with corresponding activities. So I guess I guess guys, we have 15 more minutes before the end of this very part, so I'm almost almost finished with this preliminary part, with the theoretical part. And so just before we switch to the second practical part, so let us move how a model obtained by some algorithm, so it's produced by some algorithm. We are not going to discuss how to obtain this model, corresponds to this log, you see. So say we have we have these actions again. So what is the sort of this model? So it's just a Petronet model. You see, we have positions for resources. We have activities for individual actions appearing in these, suggesting this log. And so this part is used for making a time perspective. So just to order this, order this. Events here, and you may find a correlation between what you have here as a model, what you have here as an abstracted representation of an event log, and what you have as a real event log. What you have as a real event log. So this was a task called process discovery. That one. So I think it's clear now. Okay, so welcome. So if you have questions, guys, or maybe I just want to clarify, so don't hesitate to ask me in chat. So let's now look how this model mined, so we call mining a model or discovering a model or synthesizing a model. So it depends on which specific details you wanted to suggest to focus on. And so let us look how this very specific model related to this event log so can be suggest replayed in terms of how these resources, so this token, can suggest travel through this model in order to show its very particular execution of a process, how it can make a very particular instance of a process execution, or simply a run, what we are going to discuss at the second part. So we start with the start, sorry for the repetition. So we begin with the start position. Here you see, so we have only one resource which initiate a process. So it starts it. You see this process. And so there is the only one action that can be executed right now, because so there is only one transition that is, so we call it active or activated. So it depends on what you just wanted to focus. And so now this transition is being executed, and it produces two tokens here, and we have a record. So we record that register request action is so just executed. So we recorded it, you see, and it means, okay, so now we have another instance. So someone wants to get a compensation for some, you know, insurance, some case related to insurance, you see. And you see that we have two tokens now. Why one transition can use two tokens? Because of the definition of this module, you see. So each input placed are being consumed. So just tokens from input places are being consumed, and so each output places are being filled in with tokens. So this is just a simplified version. Of course, there are different variants how one can consider more than one token at once, how one can produce more than one token at once, and so there are different interesting cases here. However, so we consider a very simple variant. So now we have three transition activated. So and you can see that so this token placed in the place called C2, labeled C2, activates this very transition, and doesn't relate to the token in place C1, which activates both of these transitions, but in this very case, only one of the blue outline transition can be executed, because here we have what is called a fork. Here we have a fork, so it means that this token can goes either here or here, but this one can goes only here, and the real specific order is not important. The order is not important. So I have a question in chat, so from Valeria Strantsova, so do not understand exactly what conformance checking means. Conformance checking, so let me get back to, so just to one slide back. So conformance checking means when we have a model, when we have a real behavior, and we try to fit real behavior with a model, and we want to see whether so it fits perfectly or there is some deviations. There are some deviations, you see. And what we are going to do right now is just to make such kind of replay. So we simply travel through the model, and see which specific, so just with specific transitions are being activated, and so just correspondingly trigger these transitions, trigger some actions. So now let's suppose that check ticket was executed first. It's not obvious that it must be executed before this one. It's simply because we deal with a discrete system, and the system must be determined. Another question, can you please explain a bit more on how it's decided which branch will be chosen at the fork? So here we have a fork. And the answer is that so it's undetermined. So it will be chosen without any specific determination. So it can be chosen this one or that one. It depends on very specific run, you see. So it's not a what is called imperative execution. It's kind of declarative system. It shows possibilities. So this model simply shows possibilities, which means that either this one or that one can be executed. And for my specific example, so now we have a fork, and for my specific example, this transition was called. This transition was executed without any specific determinism. Because so this fork gives an ability to execute this one or that one. and say if you have in a real log at this place examine casually, it means that so there is a room for such execution, or alternatively it could be examined thoroughly here, and it also we also have a room for this very case. You see, so this is specific kind of model. This is specific kind of model. So simply what we are trying to do right now is just to model control flow of this process. You see how it could suggest changes in terms of their state. And okay, now you can see that so we have two resources in the input places C3 and C4, and now the decide transition is activated and it could be fired. And so actually now there is only one transition that can be fired, this one. So at the next step we so just execute it, and we have a token here, and we have three output arcs here. So it means that we have three output suggest cases when to go. So this looks like a switch statement in a high-level programming language such as C++ or Java. Is there any switch statement in Java? So now I have doubts about that. I guess so. And okay, so let's get back to the chat. So the fork shows the various possible transition that can be done between states C1 and C3. Yeah, correct. And now, so we have another fork. So we have now we have three possible transition and only one to execute, and only one can be executed. So we have three possibility. We have three cases, and so the only one will be will be worked out. And say for this very case, okay, so say we end up with pay compensation. So just according to the very specific case, you see, because so it's just a control flow, but there are some people who are involved in this process, and so when they examine something thoroughly, it means that they examine something thoroughly. So they are looking at documents and so just making a proper decision. And now we have a token in the end position, which means that so another instance of a process have been done, have been recorded. So here we have these five events: register request, check ticket, examine casually, decide pay compensation. And let us look back to our log, what we had here. So these five events, you see, these five events presented in our log. And what we have here, so this is just a special variety of PetriNet model, which is called WFNet or workflow net. This is just a PetriNet with some specific restrictions. So we have one dedicated position for the beginning of a process, one dedicating the position for the end of the process. And so such a model must be what is called sound. And when we discuss the soundness of a model, say we can say that a process model is sound if every activity can participate in a process instance, and it's ensured that the process always terminates properly. So behavioral anomalies such as life logs, deadlocks, such anomalies violate soundness. See, and so this set of rules help us avoiding of unsound process model. Again, so this is a real log, this is abstracted log, and here we have a model, one of the possible models. So this is important to consider this article here, a model, because there could be, so just there are, I guess, infinite possible ways to create a model which satisfies to what we have here by simply adding so just some additional branches, some additional paths here. So it's unlimited way how one can extend the model, which fits to what we have in event log. So this is why we have a model here. Last few minutes before the end of this very part. So how the logs are checked upon another equation, upon a workflow net, like in the example, what if a request is reinitialized again and again. So this very model doesn't prevent reinitiating requests, so just infinitely. But if you really want to say just declare that there is possible to have only say 5, or so simply just any determined number of cases, you may add here one more position. So let me try to depict it. So if it's possible, so let me simply check whether it's possible just to write here. So you may put here another position, and put 5 tokens here. What does it mean having 5 tokens here? It means that each time when there is a chance for this transition to fire, so not only token from position C5 will be consumed, but also 1 token from this position. And finally, so just we face the case when there is no more tokens in this position. And it means that so we lock the ability for this transition to execute anymore. Got it? And so there will be only one, so just only 2 position, so just left is to pay compensation or to reject request. So finally, you have to decide what to do, but not to just iterate the client again and again with new requests and new checkings. You see, so you may model it differently. And there is quite huge theory and quite formal theory, which quite strict proofs on which model can be considered as sound and which couldn't be considered can be considered as sound. So we may prove some just propositions regarding this point. So finally, so before the end of this very part, so I wanted to simply mention, maybe enumerate or just simply consider so the presence of you see a lot of different algorithms involving only in the discovery process, but we also have a lot of algorithms for conformance checking, a lot of algorithms for enhancement. So this one is given in color here because so what we are going to do next in the next part of our class, I hope guys, so you will just visit us. So looks similar to what the fuzzy mining algorithm does. So I have to note that so most commercial process mining tools, so such as Celonis. So this is the most known so far because it have been evaluating for the for the last years, and so there were a lot of money invested in this, so just in this company and in this tool. All the banks, so just insurance companies, and so other guys love Celonis a lot. However, so I have to know that so most of these so just tools simply deal with the very simplest and sometimes very important, very useful mining algorithm, which is called fuzzy mining. And this is what we are gonna do next time in the next part here. So there are tools involved in the process mining business, and so for instance, Prom is a kind of academic tool. It's all open source tool, however, so it's quite difficult to use. There is pretty nice disco created by the ex-PhD student of Professor Ralph. So now there is a package called PM for Pi, standing for process mining for Python, I guess so. And this is what I ask you guys to prepare in advance. If you'd like to try to follow me in the second part when I will be showing some kind of master class, also just kind of practical task here. So there is Celonis mentioned, and so there is one more you can find almost so just only a few information about it. It's called VideoMine for video, and again I'm suggest emphasizing it because so this is what I was doing, I was mastering, I was developing and designing during my just research on the field of process mining. So I just homebrewed a tool, including some ideas which made the significant part of my PhD research. If you have enough time before the end of the second part, so if you'd like, I can see so what is the idea. So it's just a mix of graphical tool with so just a lot of low level so just quite hard algorithms implemented there. So this is just my personal achievement. So this is why I suggest I like to mention it. And so we're gonna deal with PM for pi. So and so now it's almost the end of the first part. And what I wanted to show you guys is just so I'd like to share a link, so please try this link. So I will duplicate it in our so just Telegram group or whatever we have. So just there is a folder, there is a Google Drive folder containing so just some example of logs we gonna use during the second part. So they are more or less big in terms of so just their size. So please download them in advance if you would like to try to follow me during the second part. So thank you for your attention. So I see so just quite big number of participants are still with me. So just big pleasure for me to work for you guys. And so now I'm so just eager to hear your questions, and I will try to answer them. The question, so I have a question in our chat. What is the distinction between data mining versus process mining versus business mining? It's a very good question. So let me say the following. So data mining is a kind of generic unified discipline. It's even not a single discipline, but it's just a framework which declares an approach based on some very essential things, very essential points. So these points are, so you have a lot of data collected due to some circumstances. You see, so it doesn't matter how did you get this data. However, so you have information systems, they are working, they are producing this data, and so this data contains some valuable information that you can use in order to suggest to teach your neural network to extract very specific knowledge about some possible suggest intrusions or something like this one. You see. And so this is just a general framework, general approach. Process mining is a so just kind of spin-off, kind of so just sort of data mining, aiming especially for extracting valuable knowledge about processes. It so just deals together with machine learning. So not only data mining, process mining also includes in its business and its work machine learning, business process intelligence, some techniques, and business process management. And regarding business mining, so it's more, I guess, so I feel it more so just how to call them, more high-level approach, which includes not only some technical approaches, not only some technical so steps needed to find a model or just to get a correlation between data. So data mining is about correlation between data. Process mining is about so just correlation expressed in terms of dynamics. And business mining is a more or less organizational approach, which helps you to maintain your business so just to keep it properly, you see, to find something what was hidden from you as a founder of your business or as an owner of your business, you see. And process mining can serve as another tool, yet another tool helping you to mine your own business. Another question, so why BPL important in process mining? So BPL is nothing else as another notation for expressing interaction between different components in another dynamic system. So BPEL is mostly used when you have an interaction between components made of what is called service-oriented architecture. And it's just leads us to dealing with software process mining. So this is just the topic we are going to discuss in the next part. Because so when you deal with software, so and if you deal with more or less complex system, which includes a lot of components and they are organized using software-oriented architecture, they are possible just to have a model expressed in terms of BPEL. But it's not obvious. It's not mandatory just to have such a model expressed in BPEL notation. So you also may consider BPMN notation for that. And I had a very particular case. So it was just a business task for me when I had a log of a system made of service-oriented approach ideas. And so this ideas was expressed, I mean, so just this technical part of the system was expressed using BPMN diagram. Another question, can you recommend any source when we can learn more what you explained until now? There are not the last slide of the presentation, this one. So now I have the part for the second part. So there are a lot of actually, so now, so far, there are a lot of sources for dealing and for learning process mining. So there is a MOOC, sorry for my pronunciation, so just massive open online course, I am correct for this abbreviation, called Process Mining, Mine Your Own Business or something like this one, so by Professor Van der Waals. So at Coursera, so it's open course, you may look at this course, so it's not only about the theory working at the backstage of the process mining, but there are also a lot of examples, a lot of exercises. So, but you also may found a lot of new information, so appearing last time in YouTube, say in YouTube. There are a lot of sources of knowledge from the guys from at TWH, University of in Aachen, where Professor Van der Waals is working right now. So there are a lot of sources. So simply Google process mining, and you find a lot of sources. Is there another, the last slide of the presentation? Okay, some other questions? Not real. Well, okay, guys, so thank you so much for your attention. So we spent exactly 1.5 hours so for this first part. So if you'd like to participate in the second part, okay, so let us so just agree that we will meet in, say, 10 or 15 minutes. How much time do we need for the pause, for the break? So guys, I'm waiting for your suggestion, but I have one more question. So inventory is an essential part of business and it poses problem a lot of times, especially in small business. Can be used for that. It's an interesting question. It's an interesting question. First of all, so this process, I mean, namely inventory process, must be accompanied using an information system. Now it's possible, I guess, so it's not a problem just to, to create these barcodes or QR codes, just to put it on the stuff. You're going to take just into account. And so you simply need to, what you're going to look, you simply want to see how so your staff are moving from the so say department to department or what. So if you have a process which includes so just issuing so just you know stuff you're going to track, just to giving it for some person, for some employee, or then just waiting whether so this stuff was not lost. So you may a very simple process. So if you accompany this process with some information system tracking these stages, so then you may apply process mining. Does process logs, I guess, process logs, the part of system logs, it depends on you have in system logs. If your system logs contains information about execution of individual programs involved in so just a more or less formalized process, then you may consider them as so just event logs. Moreover, so most often there is no special need to, sometimes it's convenient. However, there is no special need to create an event log in a very specific manner, in a very particular manner. You may use those logs that you have. And you simply need to be able to map three important attributes I mentioned. So namely case ID, so just activity, to find what serves like an activity for each specific trace, and to order them somehow. However, so almost all system logs contain information about timestamp when an individual event occurs. If so, then can we use tools like Prometheus for extracting process logs? How to deal with process logs? This is just a topic we're going to discuss in the next part, so just in the following part. So you may use any software tool which helps you to prepare a log according to what you're going to use. Possibly Prometheus works here. Okay, guys, thank you just for your questions. Again, so we need to agree where we meet. So let us try to meet at, say, at 4. Does it work? So next part is planned at 4 p.m. I mean Moscow time. I don't know. So just about your suggest is planned at 4 p.m. Okay, does it work? So 15 minutes for pause, and then we'll have another hour. So just I guess it will be enough for us, just an hour to try to do something. Try to play with some specific example. So okay, thank you guys. So then let's meet at 4. And so you have 15 minutes for so just take a rest and to download logs. Also, so let me remind you that there was a okay. Well, so my plan for the second part, guys, would be the following. So now, so let me start sharing my screen. So now we consider a very particular event log made so just of events recorded by a real system. So the system I was working almost 10 years ago, however, so just partially, so just private logs, but I guess so I can share it with you. And from my side, there will be some tools, some applications helping me with dealing with the log. Say I have so just a tool called SQLite Studio. So it's just a free manager helping dealing with SQLite databases. And here, SQLite is just a So just as an approach how to store and efficiently manipulate data of event log. So I'm going to talk a bit how so this data so just came here. However, so here you guys have CSV files, so just they are prepared CSV files. So these files were exported from this application, and so if you need, you may also, if you use any kind of so just database manager tool here, so you may import it as a table and look at so just how the approach I'm going to discuss can be applied in terms of different SQL queries, expressions, and so other stuff. So also, so we'll need a Python ID. I'm going to use JetBrains PyCharm. We see, guys, that so we all are a big supporter of JetBrains. So I have a special T-shirt for this very case here, and we need a Python installation, so a special Python installation. So I use Miniconda for that with a package called pm4py. However, so these points were mentioned previously. And let us begin with so just a bit of theory first again. So we need to look at it. So I called it cooking an event log in terms of that. So it was a question, so how one can get an event log, yeah, how one can extract an event log from a system, from a particular system, and the answer is not, so it's not very trivial sometimes. However, it's not a rocket science as well, you see. So just some specific so just some specific business, some specific activity that has been done in order to prepare data for dealing with, you see. So again, I wanted to remind that so when we consider an event log, we may look at it from different points of view. We may look at its real implementation, so very detailed table, and this time, so as I have already shown to you, so we have exactly the same table. So this time it's represented as a so just database table or database entity. So strictly speaking, this is just a subset of data so just obtained by a special SQL query from so just real data. So these two tables store real data. And so there are so just much more attributes. I'm not going to suggest to use in our analysis exercise. And here the abstracted version. So the abstracted version only will consider the name of activity. So here you can see that so we have different attributes that can serve as activities. We may consider, so there is unit name, there is one, so just it looks like as a string attribute, and so it could serve like an activity, it can work like an activity. Or say we may consider operation name attribute, and it also can look, can work, can do like activity. And so the question is how one can properly so just choose which attribute to use as an activity. And it's not trivial so just question, and we have no trivial answers for that, because it depends on which perspective, which process perspective you'd like to consider. And so you have to try, you have to so just make a little research in order to see what we can also just get when we use this or that attribute as an activity attribute. So we have timestamp attributes here, so which more or less just as it's for the business. You see, for the duty of so just ordering attribute, we have it in two forms. So one is so just you can see. So we have a real event timestamp, which is given as what is called Unix timestamp. So this is just more or less technical software detail. So I hope so you are more or less familiar with that. But there is an approach how to represent a timestamp. It's Unix timestamp, so-called Unix timestamp. Namely, it's, if I'm correct, it's a number of seconds, so just spending till 1st January of 1970 or something like that one, you see. And I have a special virtual attribute, virtual column, which gives us this timestamp as a more or less human readable variant. So we have a lot of attributes. I will come back to this log a bit later when we will discuss a subject area. So this was just a preliminary knowledge about what you have. And well, okay, so in order to finish with the equation what you have, so let us look at what you were given, guys, with. And so there is a file called full1csv. So now I'm going to open it, Sublime text editor. I suggest you also to consider so just any not experience, how to call it, powerful, so just text editor. And you can see, so here we have as the very first string, so just the labels for the same attributes I have in my so just database system, so separated by semicolon character here. And each of the following lines consist of a single event as usual. So here we have a table. Each row in a table is a single event, relates to a single event. And so here we have a CSV file with a single event per line. A single text file. Am I correct? Was I correct with that? So when we will working with it using PM4Py, so we will dealing exactly with this CSV file. So this is why I suggested to share it with you. So this is just what is called a bit of real life. So there was a question. So what is the relation between system logs and the event logs? So system logs look like this one. So this is just this is also can be called raw logs or raw data, or just presented in any formatted. Not any formatted view or such a structure. It's not structured. It's simply not structured. And the first question, how one can suggest turn the raw log to a more or less structured log. The answer is that so you have to perform a stage. Most often it's a separate stage, which is called pre-processing. And so in order to do that, so you may use different approach. So you may use even a special application. However, the problem is that so in real life, there are a lot of different ways how unstructured data can appear. And so it's sometimes quite complicated just to create a simple or single tool which can be configured by putting some parameters regarding to what we have in our so just raw data. And so this tool give you by pressing the only magic button, you see, so just big red magic button. So and by pressing this button, so you'll be given with a structured log. So no way. So there is no way to have that in most cases. So it means that you have to create so just a routine, some simple script. Python works perfectly for many cases. However, sometimes when we deal with so real big data, we may so just face with the restrictions related to the fact that Python is quite, how to call that, not non-efficient, but it's quite slow comparing with so just compiling languages such as C++ or or even C# and Java. See, so namely for this very particular event log, it was produced by a system which it was generating, actually, I don't know whether the system is working now, possibly yes, but maybe in a bit different way, in a bit different form. So it was generating almost approximately 10 gigabytes per day. Can you imagine how huge were those logs? So let's simply mention event log standards, because we even just the process mining is a research young discipline, so we have some standards. So there is IEEE standard XES for representing data in XML-like format. So there was, now it's obsolete, however, there was a format called EMXML. CSV is just a universal way just to share any tabular data. So I like it a lot. And so just the beauty of this format is that so you may easily convert it into so just any database. So you just only need to create a structure. You need to create a structure of your table. Say I have here tracing events table with the following structure, you see. And then I simply can import data using so just standard importing scheme. So I have to provide so just name of data, name of table, so just to map attributes from CSV to so just to attributes of this table, and so just make this import properly. So this so there is XES standing for extensible event stream. So and there is nothing else as XML file. So this is just an XML file with a special scheme describing what could appear here and what could not. And you can see that so a log is so just given here using the log element. So then we have some global classifiers. Then we have the trace element representing a beginning, so just the beginning of another trace. Inside of any trace, we have an event as a collection of attributes. You see, so this is just nothing else as a flattened representation of what we have in so just in this rectangle representation. So this is the log. Each trace is a collection of events. Each event is a collection of attributes. So we may think of an event log in this very key, you see. So just a log, attributes, activity. So here we have an activity, you see, and we have so just special attributes, dedicated attributes inside the event component. So it's called concept name. Most often it's used for an activity, or so it also can be represented by the activity. By this, say, string element or data element, or it can be numeric element with identifier, so just activity, you see. Timestamp is used for representing a timestamp. So this way, so you may have events with different set of attributes. Strictly speaking, when we have a rectangle table, so the number of attributes is fixed here. So because in this very case, the number of attributes is so just a number of columns in this table, or so just a number of attributes in the structure of this table. I have to mention actually that so here the number of attributes is defined not by this structure, but actually this SQL query. Because here I have what is called horizontal projection. So I simply pick up necessary attributes from a table, or maybe from a geo connection of two or more tables. And so these attributes are enumerated, so I can give them aliases and other names here, and so these names appear here as event attributes. So again, a single line is a single event, and so each field in this line corresponding to a column of this table is an event attribute. Well, so what's bad with this approach? Actually, I mean, with using XES, even it's a standard. So now I'm going to say some strange words, so addressing them to the authors of the standard. So I can do that because I'm still a part of the community, and so I don't need to share all the so just ideas of this community as the only possible way to suggest to deal say with the logs. And so my guess is that so using these events logs, they are sometimes called flat event logs. Unreadable, what that this one is unreadable, or that one. So this is just a single picture, so this is just consider it as an icon, not nothing else. Vladislav Bachkarov, if you mention this one is nothing else as so this in general, but well, okay, so can you see this one? Is it this is the trouble, maybe which one? That's fine. So and so here I wanted simply to show that so we have some kind of table, so there is not a big deal which specific data we have here. And so here we also, I just wanted to show that so there is a huge XML file with the only attributes we need to mention is log, element, trace element, and event element. And again, so the very particular data here is not important because it's only a picture illustrating what I wanted to say about this idea, you see. And so another maybe more important point, can you see this text? Because this time it's important here because we needed to be able to look the specific data. And what I have in this query, I'm not sure that so I can zoom it in. I mean to enlarge the size of this text because so there is no such an option for this database manager suggests SQLite Studio, unfortunately. Okay, so let's just get back to what which problem we can consider dealing with what is called flat event logs. Flat means so just it's simply consider one perspective. And the question is, what if we want to look at the log from another perspective? So say, so if we want to consider another attribute as to be activity, or even another attribute as to be case ID, so that we have perfectly different traces here. And so activity will be put in so just in different order here. So say we wanted to look at such perspective, or then we wanted to switch to another perspective. This is actually real models from the log. So you're given this, you see. And so this is just the same log and the different models obtained for different process perspectives, you see. What we can do right now, so if we need still, sorry, the problem is that so some tools, process mining tools, can work with only a fixed number of possible input formats of event logs. Say only with XES standard, or say CSV, which is also nothing else as a so just flat event log. So let me show it. So this one, you see, so you have a very so just very specific order of these events, and even if you want to change the order, so you need to rearrange these lines in this CSV file. Not so just, but it's not the case with database. If you so just have a database supporting SQL language, so just you may use so just different ordering. Say I have two views here, full data simply picks up some attributes from the so just the join table. And I have full data 3 ordered, so which is looks like as the previous one, but here you can see there is one more clause here, namely order by clause, which shows a specific attribute, a particular attribute that must be taken into account while sorting lines of this table. And so if you consider these two tables, you can these two data sets, because it's not real tables, it's data sets obtained by applying these two views. You can see that the order of the same events so just differs from this view to this view. So the events are ordered using different approaches, absolutely different approaches. And in order to make it efficiently, even if you have a huge event log, you only need to create another index to any attribute, to any column you would like to use in such ordering or grouping, say. There is another important clause here called grouping. We're going to look at them where we will be solving some particular tasks using SQL-based approach, you see.
Sorry, guys. Sergey has some connection problems, so he will resume the lecture, the practical part, in a couple of minutes. Sorry for inconvenience. On the bright side, this is the first technical issue we face in 3 days. So I guess that should be considered a smooth, smooth school so far in terms of connection and everything.
Finally, I'm getting back, guys. So can you see me? Can you hear me?
Yeah, sure.
I'm so sorry for that. So I have no idea what happened with my wired connection. It doesn't work at all. So now I turned to using so just my wireless connection. I guess so because I'm in the city. So I guess it will work more or less okay, even with so just sharing this screencast stream and with my video cast. Sorry for that, guys. So again, so just can you see and hear me without lags together with my screen sharing process? Yeah. Okay, thank you. So sorry again. So I will try to suggest to repair my suggest my talk, my presentation, and we were discussing the problem with flat event logs because so each time when you suggest to use these flat event logs, yeah, great. Okay, so let's try to continue. To repair this process. So sometimes process repairing is just an important part of the process mining, you see. So a colleague of mine, so just Dr. Alexey Mitsyuk, so he's working together with me in the PACE lab. So he's so just aware of research interests related to process repairing. So this is what exactly I was trying to do, but so I'm also experienced compared with him in that. Okay, so what we wanted to do right now is just to, okay, so now we have a database which works, so just which helps us to manipulate data better than flat event logs. And each time when we need a new process perspective, we simply will export, so just need the data set, a prepared data set as a flat log. However, so as I was so just talking to you guys, so just so my personal research area was related to how to make it possible using SQL-based event logs without creating such an intermediate representation. However, the tools we're going to use for log analysis process, namely PM4Py package, requires so just this flat event logs. This is why we needed to use it. Okay. Okay, so let's try to look at a very particular so just problem study related to, as I have told you, distributed information system based on service-oriented approach. So basically, when we are talking about service-oriented architecture, so we have to take into account a lot of details, which makes things complicated. So just from one, so just on the one hand and on another hand is just it make it possible to control different components spread all around the world to make their work synchronous and so just to make it properly. And so there are some points that have to be taken into account when so just we consider such kind of system. So we consider its modularity. So each specific service is an individual unit, and so these units are distributed, so they are not collected in one place. And so this is just important point, because what we have to consider is just to look at how different components interact with each other, being placed in different places. You see? And what else? So these components, individual services, so we may call them components or services regarding of which specific point of view we are considering. So they can be made of different programming languages. You see, so one component is made of so just using C++, another using Java, the third one using Python. But so they need to use some standardized protocols and so just interfaces in order to be communicate with each other. And even so, if you deal with a complex system, but which is, you see, which is insulated in some sense, which can be considered so in one place, or so just can be considered entirely at once. If you say have all the source codes and so just the source codes are placed in one repository. So you may try to apply what is called static analysis to finding some, to detecting for detecting some violations, or so just rule breakings or something like this one. However, so if you have a lot of components distributed all over the world, and so they are made of different languages, how one can apply the single technique to analyze different components made of different languages? You made by using different languages. And the only point that can so just help us do this so just business is analyzing event logs. Even these event logs are represented in different formats. We can simply use so just a preprocess so just to make them in some uniform way, you see. And then we may analyze how this distributed system is so just is working, is behaving, even so just if it consists of different components like this. You see, this is just a real picture of this information system we are going to look. And this one is another process perspective. So different services so interact with each other using different ways. How one can so just analyze them so without making a proper level of abstraction. You see. So again, so this is just the system we are going to analyze. It's just online booking system for ordering tickets. I mentioned that it produces a huge amount of data. However, maybe now 10 gigabytes per day is not so huge as it was 10 years ago. And what we wanted to so just to find in these logs, we need a problem to solve. We need some equations to try to discuss, try to solve, and the equations are the following. So first of all, we may mention so-called patterns and anti-patterns in terms of project structure of how these so just components are structured and how they interact with each other. So you see there is a well-known book such as by Genkov 4, the Genkov 4 about so just design patterns. And so there is similar patterns in the software world. And also there are patterns, and also there are anti-patterns. So such cases that must not appear in real solar system because they could make them so just vulnerable. Then so just can make it inefficient. So what else? Then may open attack vector or something like this one, you see. So we would like to find such anti-patterns if there are in this system, and we know that there are some of them. So this is what this is exactly what we would like to find. So another violation of architectural principles. So there could be some so just teams-based rules So rules applicable for very specific teams on how these components must interact with each other. And such rules are normally so just declared in terms of architectural principles, you see. And if we can look at other anomalies, we also may take them into account. So here we have a source of what could be considered as good behavior and not good behavior. We have a lot of best practices. We have a lot of suggest books, a lot of set of SIPs. We have so there is an initiative called SOFA, Service-Oriented Framework for Analysis. So this is just we may consider it as a set of cards with different rules, and these rules are based on idea of metrics, numeric metrics, and so how often this or that service is being called or calls another service. Is there any necessary communication between two services, and so on. And these rules can be converted, so just in you see in some signs that we are looking at looking for in our event log or in our so just process model. So if we have such signs of the presence of such anti-pattern, so then we may investigate it thoroughly and find whether we have this pattern violation or we have no any pattern violation. Okay, so now I'm going to switch to Python, so just to PyCharm, namely to PyCharm, in order to show how one can use PM4Py in order to create some process models. And so here you may try to follow me. However, so now we have not so much time before the end. So maybe so it will be easy for you then just to look the recorded video. So you simply just to I will share the code I prepared for that, and so you will try it on your own later. So what we would like to do is just to combine together two approaches. So first one is based on Python, so just scripts, and another is based on how SQL-based approach can help you to generalize what we will find using the scripts or something like this one. You see. So let me create a new project. So now I'm simply to show you. So this is just a new project wizard dialog, which helps me to create a new Python project. So let me put it, say, scripts. So I'm going to create a folder here, scripts. Now I'm going to paste it here, scripts, and so let it be SRA for system run analysis. This one, okay. So I have a pre-configured mini conda Python environment for that. So as I was told you, and I don't need any main py file. So I'm going to create my own here. So I'm going to create new window in order to be able to use some code snippets. Of course, I have some code prepared for this demonstration, so I'm not going to make anything from scratch, totally from scratch. So thank you for this tip. So guys, could you please write in the chat so whether you can see so just my PyCharm IDE. Does it work for you? Okay, thank you. So, okay, so let us try, let us start with creating a new Python script, So I'm going to create a new Python file. So the name for this file would be, have no idea, let it be PM, standing for process mining. Why not? Let's try to do that. Okay, so now it's empty, and so as usual, when you start dealing with a new, so just a new application, so it's better to check whether it can work from scratch maybe a little zoom. Okay, so I will try. Oh, so just control. No. So let me guys look at the settings. So there must be an option which helps. So with how to do that? Zoom in, Control plus, zoom images, zoom in, no, that one. Mouse. There is an option which allows to use mouse. If I search for presentation, not in the setting. Okay, so let me use this one. View, where is that? To appearance, enter presentation. Oh, this one. Okay, let's try to do that. Yeah. Let's try to do that. And okay, so now what I'm going to do is just to start with a very simple application. As usual, we use a normal approach for Python. So we check if the name of the current model is main. So we simply output some information. Before we can run it, we need to add a run configuration. And here it's important just to add to this configuration just a path to graph this component in order to be able to visualize what we have built. So now I'm going to create new configuration. So we need just a simple Python. The path to the script would be, I guess, the path to my file, to this one. So we don't need any parameters here. And here, guys, so please so just pay your attention that we have to modify environment variables, namely the path variables, in order to add the path to graph this component, because for my setting is not included in the system path. So let me do that. So programs, graph this and this one. So I have this path for that. And so I'm going to modify it by adding, you see, so this graph is so C program. So now I use Windows here. So graph is 2.38 bin. So now I'm adding here in the local path. So okay, you can see. So this just modification is reflected here. And what I need to do next, I guess it's okay. So it seems it's okay. So let us try to run this very simple application. It's very strange for me to suggest to work in this presentation mode. I've never been working with it. So I prefer simply just to zoom in using just a mouse wheel. However, this time, okay, so let me learn something new for me. So you can see that in the console, so just in the console window, we have these so just this message. So it seems like we configure it properly. So next, what we have to do is just to import so just two packages needed for dealing with process mining. This is pandas. I guess you know that because it's used for different data analyzing tasks in Python. And so there is PM4Py that has been installed by using pip install PM4Py package. And so let us start with mentioning the very first event log. So I know what is the path to my event log, and I simply create so just a global variable containing the string, so just which is the path to this very specific file, to this file full one, so just point CSV. This one. So this is exactly the file I gave to you guys. And so let's try with creating the very first, so just the very first script. So maybe, so I planned initially, I planned to finish at 5, but you suggest due to my technical issues, maybe, so I will ask you for 5 more minutes, so we will end at 5.5, okay? So in order to show different approaches. So, okay, so let us try to read this event log and to build a process map. So just the first model, we can call the build process map. So let it be the first approach, because we will consider different approaches. And so now we have to just to read this log file, and because its internal format is CSV, we're going to use pandas here for reading this file. And so there is a standard read CSV procedure here, and we simply need just to indicate the semicolon is used here as a separator, And so then there is, so I call this just intermediate representation, so just of the log as CSV log, and then now I'm going to consider it as a process mining related log. So there is a method called format data frame inside PM4Py, so just package, and it gets on its input a data frame from pandas. Strictly speaking, you can use two approaches: object log, if you read XES file, and so just data frame from pandas. Here I'm going mostly work with so pandas data frames. You see, then you can see there are some important attributes to mention. So the case ID, activity key, and timestamp key. And so here we really need to map attributes in our event log to 3 important components. Again, so case ID is used for grouping events in traces, traces. Activity keys is an attribute which indicates which specific activity we would like to consider here. And so now I'm using unit name attribute, because unit name so just more or less so just big structuring, you see. So this unit name may contain different packages. Each package may contain different interfaces, and each interface may contain different operations, you see. So this is just a quite top level of this hierarchy, and I really wanted to see how these, so just how these unit names interacts with each other, because we have some restrictions, and we would like to see how these restrictions would be could be so just violated. And then we need a so just we need a way to order these components. So time st attribute works perfectly for that, because it simply gives us just the timestamp representation, you see. Well, now we have this log, and then we may so just do something with this log. Say the simplest way we can so just explore this log is just to look how events do we have here, and how many events do we have here, and how many cases do we have here. So for doing that, so we simply call the standard Python method len, and it so just looks how many rows we have in this data frame, because now log CSV simply is a data frame, you see. And then say we have to look how many start activities and end activities we have, and what are these activities, and we also may output these activities, you see. So this is the first, so just the first so just the first part of code I would like to try. I would like to try. And so let me wait for the debugger. see, guys, so we have no time at all for doing with it. With this comprehensively, so nothing happened because I didn't call this method. I didn't call it, so let me add suggest the call for this method in suggest in the main function. So if you can call it main function in the main part of your application. So let us try to build at least one graphical model in order to see the violation of architectural principles, some architectural principles. Because I had a lot of stuff to show, but unfortunately we have no enough time for that. This time maybe, so we'll have a special session for that. Okay, so let's try to trace it one by one, step by step. So we read the first file. I hope it will work properly. It takes some time because it's quite huge actually. So then we format it using these attributes for mapping. So now we can determine number of events. So here you can see that, so it's almost 500,000 events. So it's quite big log actually. And so they are grouped in so just almost 20,000 of cases of traces here, you see. So then we have a set of start activities, we have a set of end activities, we may output them. And so if you look at the console, you can see that so these processes suggest process instances reported in these logs started with the following activities: with the author, with the search, with the backup, with the special suggest a unit name. So they reflect the unit names appearing in our event logs, these ones, you see. And so the first part, so at least we were able to see that, so we may read this log and we may get the primarily statistics for that. And what I'm going to do next is just to part only those events which reflected to interaction between process groups, so-called process groups. There are also suggest groups for services, but we are interested only in process groups now, because there is a rule, and I really want to show this rule. So where is this rule? So could you please show me this rule? This one. So these process groups can't interact with each other except of the case when they interact between a special content process group. So you can see there are different process groups here. You see these ones, you see, and they can interact only through content process group. There is a rule. This is an architectural rule defined by the suggest those guys who created this system. And because content here is a special process group which consists of so-called common routines. And the point is, if there any interaction between other process group directly without involving this content, it means that we have suggest a violation of this rule. And it suggests related most commonly to the case when there were some deadlines and developers try to suggest not to so just try to meet it properly. You see these deadlines and hacked a bit when coding, you see. So this is what we wanted to discuss in our code, and in order to do that, we need to filter it. So just to filter this event log, and there is so just a special method called apply event. So this filter gives us only those so just traces which consist of attribute PR here related to suggest a process group in the attribute called int type. So this one. And so I have an alias for suggest attribute filter component I had to involve it here. So it's declared in the algo filtering pandas attributes package, and there is a component attribute attributes filter, and I called it panda as a prefix for pandas attribute filter. You see, so we filtered our event log. We filtered it a bit, and what we are going to do next is just to visualize it. So just visualize the result as a, what is called direct following graph. So we would like to see all the pairs in so just of events that communicate with each other directly. Say if you have an operation from so just unit Bocamo, say this perform native mode, which calls another operation from the unit process unit ACCUST, it's something like related to accounting, you see. So we may simply say that this unit communicates with this unit directly in one step. And in order to do that, so we have to so build what is called DFG, direct following graph. And so there is a method called discover direct following graph inside PM4Py package, you see. I simply here created an intermediate variable because so we may create different filters and would like to so just visualize only the result so just obtained after applying another filter. So in order to have so just a common variable for the log, so just for the real data frame we would like to visualize here. So this is why I created this another undirect variable. So this discover DFG method gives you three components. So the direct follow graph itself and the set of start and end activities. So we have to mention that actually, so we have the start and the end activities calculated or determined previously. So, however, this algorithm simply so just determines the presence of start and end activities on its own. And now, so we simply call view DFG method inside this package, so and supply it with the graph itself and two sets of the start and end activities. So this visualizing method uses graph with component in order to make a graphical representation of our model. And so this parameter shows that I wanted to have a PDF version of this model. So let us create so just the only one graphical representation, look how it works, and so just look at this model and we'll try to find is there so any violation. So we have only 1 or 2 minutes, and so this is just the only thing we can see as a as a proof of concept, of the idea, and the ideas are presented here. Again, so we read the initial CSV file. So if you'd like, guys, I may simply share all the code because I have a lot of code prepared for this time. So I can simply share it after this. So just after this, how to call this class. And so you will try to use it on your own. And so then if you will have any questions, so you may ask me, so just to write me. And so let us simply just make this class a bit longer, however, in asynchronous mode. Okay. So we create again, so just we format a data frame, so it takes some time. So again, so we have this number of cases and events. So we output start and end activities. Then we apply this filter. I hope it will work okay. And so now the time just to discover direct following graph. So it also takes some time. It depends on how many components do you have here. Sometimes if you have so just 1,000 or 10,000 of vertices and edges, it can take say a minute, but it's much more longer to create a graphical representation, and it doesn't relate to this specific library. It relates to GraphViz component, which needs some time to illustrate what we have here. And now you can see that there is a PDF file. So this PDF file represents a graphical model. Yeah, finally, we have a graphical model. So this is just a graph-based graphical model. You see, this the very first, the simplest possible model, which consists of only 10 vertices related to accused, so just ACS up, this content, this Bacamo, this search, so the domains appearing in your event logs, you see. And this graphical model, because of its nature, that's of such interaction is between these domains, these groups, and the content process group. We mentioned that
Sergey has troubles again with connection.
the technical equipment against me this time permanently. So I'm coming back for the very last minutes. I just wanted to say that we have so just individual communication between services, but also they are quite rare communications. We have 10,000 of so just messages between you see this content process group with other process groups, and only few or sometimes several communications between these so just components, individual communication between these components. And so all these, all such communications are the violation of so just the architectural principles we know we have to satisfy. Then we may investigate them more precisely using just suggest different approaches if you are interested in details, because so we can simply just to consider it comprehensively during just this limited time span. So you may look at the paper, so just authored by so me and Vladimir Rubin. So it's, you see, it's dated by 2013. However, so it's quite interesting to look how the method provided here and explained here and described here can be applied for the modern systems. Okay, so enough for today, guys. So let's call it a day. Sorry for my so just technical issues. So these you see these disconnections which made the last part of our class a bit messy. I'm so sorry for that. However, so let's think of it as so it's just a huge area, and there are a lot of methods. And so let us consider it as a very first teaser, which I hope so, so just had your interest for this area, and so you suggest you will investigate new methods, new approaches, and find them applicable and useful for your so just real tasks and problems. So I guess we have no more time even for questions so far. So, but if you'd like, you may you may reach me directly using Telegram channel. So just our group here. Thank you for your attention, guys, and for your patience. and see you. Have a good time for the last talk of today. Bye bye.